Hi everyone and welcome to AXA Arctic Live. It's fantastic to have you all with us for this ocean acidification live investigation. As you may have worked out in the past few minutes, we had a total comms blackout up here in the Arctic. We are blaming NASA for unloading rockets just down on at the harbour. But probably something much more mundane than that. But thanks so much for joining this live lesson. Just before we start, a little bit of housekeeping. We have an amazing interaction app, which you've probably seen beside the video, or you might have it open on a second device so you can have our video stream full screen. We use that for communicating with you in case there's an issue. We also put your questions in there, upvote questions, and that's using the thumbs up icon next to each question. And lastly, if you do need to get technical support, you've probably been hammering technical support for the past few minutes, wondering what's going on, that's the chat button. The sort of greeny blue chat button at the bottom right of each web page. As we've been delayed, what we're going to do is we will extend at the end. The Q&A section will run longer than the planned lesson time. If you do have to leave right on time, please think about reposting your question with a sort of brackets, need to leave early, need to leave on time, so that we know to prioritize those questions first. I hope that makes sense to everyone watching. We've got a few shout outs to do, then we'll show you around where we are and then get down to some of the science. So first of all, we have a shout out to year 3 at Sandridge School in Hertfordshire. Hi to all year 3. We have, hi Jamie, hope it's all going really well. Please give a big shout out to all of the incredible children in horse chestnut class at Kemble Primary School. And that's from Miss Young. Hi to Miss Young, Pippa, and all the children at horse chestnut class at Kemble Primary School. Fantastic to have you with us. A big Arctic hello to you. Hello to the amazing year 7s and Mrs. Perry at the Nuneaton Academy. A big hello from year 6 at Penthorpe in Rudgwick, and great to have you back live too. Big shout out to the Grange Primary School in Bootle in Liverpool. And we have Amaya, our budding marine ecologist who's homeschooled, who's joining us too. Fantastic to have you all with us. Before we get started on the acid Arctic, the question, the investigation we're doing, I'm just going to see if we can give you a quick view around outside just here. Got amazing view through the window, but I think easier with the camera to have a look outside. So I'm going to bring the mic round so you can still hear me. Everything has to be wired in the Arctic. There's no sort of like wireless tech up here because that interferes with the science experiments. And what I'm going to ask is, I'm not quite sure how long the lead is, but I think if I do that, get the wires, there we are, Ellie can come around the corner and give you a good view of what's happening. So outside, you'll be able to see along the fjord, that's where we have been studying ocean acidification. The first trip up here I did was in 2014. And then subsequent investigations and field research in 2018 and 2019. Amazing to think that the glacier front at the end there is about 15 kilometers away, although it seems much, much closer. And there's quite a lot of ice around in the fjord at the moment, just on the foreshore, and probably from the glacier front breaking off. But what we've been doing over the past years is looking at how the pH, the acid level of this ocean has been changing, and also we've been seeing how that affects the creatures living in this amazing place. Ellie, who's behind the camera, is probably going to come in before her fingers fall off. It's a relatively warm day today. It's only sort of minus 14, but with the wind, it can feel like it's sort of down to minus 20, 25. Oh, there we go. Keep the cold out, and we'll come back. Fantastic. So we have today's live lesson all about ocean acidification. We've got a range of age groups from year 7 down to year 3. So what we'll do is we'll just take it pretty basically, and we'll talk about carbon dioxide really, and how this process works. And then what we'll do together is we'll do a couple of little investigations and see whether we can get a sense of what is going on and how it might affect life that lives in places like the fjord outside the Arctic Ocean. The first thing I want to talk to you about is a really important measure. So we're going to talk about how we measure acidity, and there's lots of different ways of doing that. And I think we've got a scale which we can show you on screen, and it really goes from low numbers, which are very, very acidic, to high numbers, which are what we can call alkali. And in the middle we have 7, which is sort of fresh water, and going from that either side. So you might have, for instance, some items that you know quite well. You might have sort of lemon juice as an acid. You might have vinegar as an acid, tomato, coffee, fizzy drinks, all the way down to sort of stronger sort of battery acids. Then on the it's a scale like temperature. You go down one way, you get more acid. You go the other way, you get less acid toward the bleachers and the detergents on the other side. So we're going to be using this idea of pH to measure change in the ocean. So think of it a bit like measuring either distance or temperature. That's our measurement unit for today, is pH. We'll come on to the ways that we can measure it in just a bit when we look at our first investigation. But I want to come on now to this idea of ocean acidification. So the idea is that in the atmosphere there are lots of different gases: oxygen, nitrogen, and one of them, carbon dioxide. You might have heard about carbon dioxide in the big discussion around climate change that's happening at the moment and how that is affecting our planet. Carbon dioxide also has another effect on our planet. When levels of carbon dioxide rise in the atmosphere, that is also absorbed into the ocean. So we've got the chemical symbol. For some of you, you might recognize chemical symbols. Some of you might not. It doesn't matter in terms of understanding these ideas. Carbon dioxide, or CO2, added to water, or H2O, then forms a weak acid. It's written in chemical symbols, H2CO3, but that's just a way of saying carbonic acid. So what we're looking at here is one of the other effects of increased levels of carbon dioxide in the atmosphere is causing the ocean to become more acid. Now, our first investigation is going to test this idea. If we put carbon dioxide into an ocean, will it become more acid? And we're going to take this bit slowly to allow you to get prepared in your classroom as well. What you'll need for this are three main things. You'll need a beaker or cup of water. This is your mini ocean. You shouldn't fill it too full. I've got mine about 2/5 the way up, nearly half the way up. That's great, but over half might cause splashes later on. The second thing you'll need is a straw. This is my straw here. I hope it's still okay. It's been in a box in the Arctic for a couple of years, but we've given it a little bit of a rinse. And the third thing that we're going to need is a way of measuring the pH, the acidity level of the ocean. Here, I've got some litmus paper, and this paper changes colour depending on the pH of the liquid. So if I put it into a very acid liquid, it's going to be on the red side. Neutral, pH about 7, it's going to be in the greeny yellow area, and then we've got the purples all the way to the most alkali liquids that we might find. What we're going to do is we're going to measure the pH of our ocean. We're going to blow through that ocean for about a minute or so. And because when we breathe out, we have more carbon dioxide in our breath, we are then adding that carbon dioxide to the ocean, to our mini ocean. At the end of a minute, we're going to measure our pH again and see whether there has been a change. In the classroom, you may have an electronic pH meter. You may also be using a natural pH indicator, such as that made using red cabbage. Do put in any comments if you need any help around pH indicators, and we'll get those up in the chat and we can chat through those in just a bit. So, before we do this, I'm going to put a poll up and I want you to predict the change that will happen, or maybe there will be no change. If I blow through a straw and bubble that through a beaker of water, what will happen? And you'll see there are three choices for this poll. There is the pH of the ocean will decrease. That means get more acidic. So remember, as the numbers go down, the acidity is increased. The pH of the ocean will stay the same. Maybe blowing through this won't have any difference, make any difference on the ocean. And last, the pH of the ocean will increase or get less acidic. So just think about what might happen to the pH level of the ocean, the acidity, as we add carbon dioxide. I'll just give you a few moments just to reflect on that, and then we'll all get together and time a minute of blowing through the ocean. I'm going to get a thumbs up from Ellie when we're good to start. Adding some carbon dioxide here. Ellie's going to tell me also when we start the minute counter, so I hope you're ready in the classroom too.
Okay. 3, 2, 1, go.
I'm such a bad scientist, Ellie. I forgot to measure my water before I put my pH in. Such a bad scientist. What I'm going to do is I've got some spare water here from the same tap, and I'm just going to duck down and get another container. Here we go. I hope you didn't forget as much as I did. And what we're going to do is we're going to compare these two. So, rip off a strip of the pH litmus paper. I'm going to make a space here for the before, and we'll rip off another strip. And we'll see how those react over the next little bit. So just to talk through, do we have the results of the poll come through?
So 70% say it will decrease, get more acidic.
So 70% absolutely brilliant. What were the 70% of you predicted it will change? What were the other 30%?
15% said it will stay the same, 15% get less acidic, pH will increase.
Excellent. So good to see, because we've got a variety of different opinions. And the important thing in science, I'm going to get some, is then to be able to test what you are doing. So we'll put these on. That's going to... So I'm just going to duck down here. I'll bring these up so I can hold them up more easily. So what I can clearly see on my results is in this hand I have these green patches here showing that it is more like about 7 a bit in terms of pH, and then the yellow here we've got 6. So I've dropped by about a unit of pH just by blowing through that for a minute. If we get that second poll up, Ellie, we'll be able to ask the classes what they observed. Did they observe the pH decreasing, whether the pH stayed the same, or whether the pH increased. And this litmus paper just taking a bit of time to react. But I'll just put that down here so you can very clearly see the difference between those two. The green on the right hand side and the yellow on the left hand side. And so in this next section of the lesson, we'll just see what you managed to observe. In this next section of the lesson, we're going to think about what the point of studying this is. Why does it matter if the pH of the ocean changes? Now, in about 1750, the average pH of the ocean was 8.2. Now, the ocean's got a higher pH than the rest of the world. I mean, the ocean's got a higher pH than fresh water. And it's about 8.2. And on average, it has decreased to about pH 8.1 since 1750 to the present day. Now that 0.1 of a unit of pH may not sound like very much, but it represents a 30% increase in acidity. Now, if you sat in the classroom and had a 30% increase in your blood acidity, your teacher would be calling an ambulance very, very quickly to get you straight to the hospital. So that change in acidity has happened on average across the world. When we look at the fjord out here, we find it a little bit lower in pH again. And that's because there's so much ice, freshwater ice, melting into the fjord. Now, when we change the pH of the ocean, it has an impact on lots of animals because they're swimming around in this ocean where the chemistry is changing and they have to work harder to keep their body chemistry stable. But it's especially difficult for creatures that have a calcium carbonate shell or skeleton. So think about crustaceans such as crab, mollusks such as oysters or mussels, building their structures out of this mineral that's in the ocean. And what we're going to do next is we're going to have a look at what impact an acid has on this mineral calcium carbonate. So for this, you just need three things. You need your shelled organism. So you can use bits of chalk for this. You need an acid. Ooh. In this case, I'm using vinegar. You can use shop-bought vinegar, but be very careful. If you're in Norway, I've found out that the pickling vinegar they use here is 5 to 7 times as strong as normal vinegar that you get in the shop in the UK. So when I'm going to do my demonstration up here, I'm going to have my goggles on and my gloves on as well. There's a safety. Who knew that vinegar could get so strong? So there's a safety sign on the back of this. I'm just going to bring my mini ocean over and place some darker coloured chalk in here. If you are using sort of more modern chalk, sometimes there is a coating over the outside of it to stop you getting chalk on your fingers. So it's really good to break it up into smaller pieces so you've got those edges that can react. And all we're going to do here, and if you're following in the classroom as well, is pour some vinegar on. And see what happens. And I'll hold it up for you in a bit and try not to knock myself out with the strong smell of vinegar. Eddie, is it good better to hold it up or leave it on the table? Bring it forward. And get a good shot and see what's happening there. So as you can see, that chalk is reacting quite rapidly. The acid and the base, the acid and the chalk. And just to remind you, that is not what's happening in the ocean at the moment. I'll dip a piece of pH litmus paper in here for you just to show how strong this is compared to even fresh water. Let's grab that and I'll place it beside. So if I place that down here, you can see immediately this orangey red colour showing how acidic this is. What we're not going to see in the ocean are shells dissolving like this. The projections are potentially by the end of the century we could get down to pH 7.8. That depends on how much carbon dioxide is in the atmosphere. And what that will mean for these kind of creatures, and we can show you some pictures of pteropods, one of the types of plankton that live in the ocean up here, is they're going to find life much tougher in terms of building their shells. They might be thinner, they might be more pitted, they might not provide as much protection from predators. And if they're putting so much energy into making their shells, they may not have as much energy for other functions like growing, making more pteropods or amphipods or other types of plankton, and even in moving around to find food. So what we are predicting and seeing, in fact, is that with more carbon dioxide in the atmosphere, we're seeing a change in the pH of the ocean, and that change is having an impact on some of the creatures, not all, some of the creatures that live in the ocean. So during this live investigation, we really just wanted to share with you these two ideas, that adding carbon dioxide to the ocean can change its pH, and also that change in pH can have an impact on creatures with chalky calcium carbonate skeletons and structures. So fantastic to talk through those two parts of the investigation. And now what we'll look at are some of the questions that you've come up with. Brilliant. The first question is asked by Amaya, and it is climate change going to affect how much carbon dioxide is in the ocean? Amaya, it's a really good question, and it could well do. So the warmth of the ocean changes how much gas can be stored in it. So the warmer an ocean, less gas can be stored in it. The cold ocean up here, you can have more carbon dioxide dissolved in the ocean. And you can tell that, you know that, because if you have a fizzy drink and it's cold and you open it, it might not spray anywhere because the carbon dioxide still sort of, a lot of it's dissolved. If you have a warm one on a warm sunny day and you open it, it can spray everywhere because less of that carbon dioxide is dissolved in the drink. It's a really great question. This is from Penthorpe. Carbon dioxide is only a small part of the atmosphere, so why does it have such a massive effect? It's a great question, Penthorpe. You could say the same thing about sleeping in a big bedroom with a single mosquito, that small things can have a big impact. So I think what we're really talking here is about balance in natural systems and the role that carbon dioxide plays on the planet. One of the chief ways, as you know, is it's provided this sort of blanket for planet Earth as a layer in our atmosphere, and that's made life possible. However, the changes that we're seeing in the levels of carbon dioxide are significant in terms of changing the sort of the amount of carbon dioxide in the atmosphere. So even a small change can have a big impact. Likewise, in the ocean, there's been an ongoing relationship between acidification, so carbon dioxide being dissolved in the ocean, and what's called buffering. And that is where, think about the White Cliffs of Dover. That is all chalky coastline, that being dissolved into the ocean, and those two processes cancelling each other out, being in balance. As soon as we change the balance of these natural processes, even if it's a small part, it seems small, then it can get out of balance and we can see the effects that we've just been talking about. But really, really good question. But I like the analogy. Someone said to me, if you don't think something small can make a difference, spend a night in a room with a mosquito. So we'll move on to the next one, which is Nuneaton Academy. What is it like to be a scientist working in the Arctic? Great question. I've had the privilege of working with scientists in the Arctic for over 10 years now. And for all of the times I've worked with them, I think the main thing has been they're just blown over by how beautiful and how amazing this place is, how important it is for our planet, and sort of how privileged they are to work in this environment, and how hard fought for the data is when it's based on field work. So you have scientists, they're not necessarily sort of very sort of like outdoorsy, amazing, sort of ski across, everything explorers, but they're super passionate. Of course, some of them are, but they're super passionate, super curious, and willing to put up with temperatures down to -40, willing and colder, willing to put up this discomfort just to answer the questions about how this planet is changing. So, amazing question. And so that's what I'd say about sort of what's it like for scientists working in the Arctic. From Kemble Primary School, what do you love most about the Arctic? I would say the amazing view, but just as we've been talking, the clouds come in, and I can see a few hundred meters, and that's about it. But it is. I would say the light in the Arctic is amazing. It changes the whole time. In spring, you get the northern lights, the aurora. This time of year, the sun just goes round in a big loop, never sets, and everywhere it goes, it sort of changes the way the landscape looks. So just absolutely incredible. From Sandridge Primary School, we have what can we do here in the UK to help stop ocean acidification? It's a great question from Sandridge. Basically, there are lots of different ways that you can help reduce the level of carbon dioxide in the atmosphere. We'll be going through a lot of those on Thursday at the same time as this at 2 p.m. So we have a great polar conservationist who will also be talking to us a little bit about work in Antarctica as well. But you can think about travel, food, and life in general, and look at those three areas. I'm sure you and your teachers can come up with some ideas about how to reduce your carbon emissions in those areas. Has the whole of the Arctic Ocean become more acidic, or is it just certain areas? That's an awesome question. We don't know, just to be honest, because your sampling rate, you might not be able to get everywhere to sample, and so the as I mentioned before, the pH of the ocean is very much, especially near shore, is very much affected by the lots of fresh water coming off glaciers. If you're measuring it off the coast of Siberia, you've got a lot of fresh water coming from somewhere like the River Ob. If you're measuring it on the Canadian coast, you've got the Mackenzie, a big river there. Near Greenland, of course, meltwater coming off there. With the freezing and thawing of sea ice, you're going to have it altered at different depths. With the freshening and salinity, more salt in those levels. So people try and sort of work out through different ships that have gone on different places or different ice bases, or work here a sort of average for the region. I don't have the most up-to-date average for the region, but it is one of those difficulties, especially with great things still areas of the Arctic Ocean that are not navigable. So finding out the pH of the ocean entirely is tough, but it's also some more I think remote sensing, so the ability to do some of this work by satellite in the future, which will make getting a good average much better. I'm going to answer these questions. So Hugo from Turtle Class, are there any penguins? Stacks of penguins up here, but they all got eaten by the polar bears last weekend. No, so penguins. sorry, Hugo. It's a really, really common misconception. We're up at the top. Polar bears, reindeer, Arctic foxes, penguins down in Antarctica. One colony of penguins, I think, just sneaking over the equator into the northern hemisphere in the Galapagos, but mainly penguins down in the southern hemisphere. And there's a saying that the only place where polar bears and penguins could ever meet is a zoo. But Hugh, great question there. From Mrs. Richardson Miller's class from Jacksonville, Florida. Hi, everyone there. Does the decrease in ocean pH shorten an animal's lifespan? It could well do. So what we're looking at is the stress. The experiments that we're doing in the Arctic a few years ago, looking at the effect on mortality levels, especially for larvae, saw that in the future ocean that we're going to see possibly a lot of the larval stage of two of these species of plankton are not survive as much. So in terms of lifespan, we're seeing that being shortened on average. And yes, if you've got less energy for living because you're making your shell, then there's a possibility that it will decrease lifespan. There's been a lot of work just in the US, in Washington State, I think it's been going on for a good long time, with looking at the oyster fisheries in Washington State and the impact of ocean acidification, especially on the baby stage, on the larval stage for the oysters there. So do have a look at that as well. This is great. Has ice ever cracked where you are? Ruby, thank you very much. I have managed to put my foot through the sea ice. The first time I walked on sea ice, put my foot through, which was cold and uncomfortable. But luckily, we were near where we were staying, and so that wasn't too bad. But we had a crack near a skiway through when we were living on the ice, about 1.5 meters thick. And also there's great photograph which we can find on the Encounter EDU website at a later date, which is where explorers connected to the scientists who we were working with. The ice cracked right under their tent when they were asleep. So that was a fairly frightening experience. Great. So just going through, are there beluga whales around you? We haven't seen any this year, but we have seen them up in this area before. An amazing, amazing sight. So we do hope to see them again. Is there summer in the North Pole? This is late spring. Summer coming soon. Summer will see most of this snow melt. So it'll be open tundra. So there is summer. Also in the North Pole, we're not quite at the North Pole, but in the Arctic there's summer. So the big change is the amount of daylight. So 24 hours daylight in the summer, and in the winter 24 hours of darkness. So of course that's going to have an impact on life and the amount of ice and cold and everything else. Can you tell us about an animal encounter we've had here? We haven't been too close. There is a rogue Arctic fox who's hiding from us. We saw paw prints just outside the garage door this morning, and we're waiting for the fox to sort of appear and do a little dance for us behind here. We've got a photograph from previous years where we've seen it out of the window, but we're still waiting for the Arctic fox to come. Luckily, no polar bears in our settlement over the past few days, so that's good. Don't want to come across one of those walking around. And then lots of bird life and a few seals and some reindeer around, but no ferocious or even sort of like close-up animal encounters quite yet. I'm going to combine Nuneaton Academy's question, what kind of animals and plants able to grow and live in the Arctic, with one of those ideas about sort of removing the amount of sort of carbon in the atmosphere or decreasing that. There are no trees in the Arctic at the moment, and so weirdly, if you planted trees in the UK, that would help there to be no trees in the Arctic, which is what we're looking for. But in terms of the animals, mostly bird life, eider, ducks, snow bunting, ptarmigan we've had up here. Whale life, we haven't seen any this year, but you get beluga, minke, humpback, and blue whales up here. There's some walrus just down the coast. So polar bears apparently will start coming over from the east coast as the geese come in to nest on the islands, because they're now sort of like foraging on where the geese are when they come over. What is one thing each of us could do to help the problem of acid oceans? Really, just it's all about carbon emissions, and that's to everybody at Campbell. I would just look, even if you're not going to join us for the lesson on Thursday, have a look at caring for the Arctic lesson, because there's a whole bunch of resources on there that take you through some of the impacts of a warming ocean, but the pledge cards and the pledge ideas, all of those as a class, individually, as a school, will help to get you on the sort of journey towards decreasing your carbon emissions. We've got 3 more questions. How long is the ice in the Arctic going to last? A very, 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 very long time. So I think that there's some things that we need to sort of clear up. We're talking all about ice tomorrow. First of all, the Greenland ice sheet, huge, decreasing, yes, probably be around for quite a long time. Winter sea ice in the Arctic, again, likely to be winter sea ice in the Arctic for a very long time. When people talk about there being no ice in the Arctic anymore, or the Arctic Ocean, they're normally referring to summer sea ice and multi-year ice. Multi-year ice, big, thick ice, super, super important. And so there's a prediction that there'll be sort of no proper sort of permanent sea ice, so that lasts through the summer into the winter and back into the summer and over and over again in 20 to sort of 40 years are some of the current estimates. It's a question that scientists are asking lots and lots and trying to work out what some of the missing factors may be as they try and predict these changes happening. But 20 to 40 years is a bracket that quite a few scientists are talking about. Have you ever seen a polar bear? I've been on trips where polar bears have been seen. I've never seen a polar bear. I'm waiting. I'll just, after the end of this live lesson, I'll probably sort of keep an eye out back, see if any come through. So really still waiting to see a polar bear. Last but by no means least, Eastern Academy. How do you live in the Arctic? What resources do you need? It really depends. Here we're at in an international sort of research village. We're at the UK station. Our food is catered, brought in by boat. We have bedrooms. We have showers. It is really great, and we can set up with power. And as long as the internet works, we can speak to you guys. But of course, you can be in what's called a deep field, and then you are based in tents and surviving in that way. Thank you so much for all your questions. Thank you so much for being part of AXA Arctic Live again, and look forward to seeing you tomorrow for a lesson on sea level rise, and then on Thursday we are looking at caring for the Arctic. Until then, goodbye from us. Bye bye.